Would you like to write code faster and smarter with rich code completion and clever code analysis? Find anything in a solution instantly? What if you could easily explore and run tests, work with Git, Mercurial, or TFS seamlessly, and refactor in a few clicks? All this and more is available in JetBrains Writer, a .NET IDE for Windows, Mac, and Linux. Try it free for 30 days. Get Writer today at rideride.net. That's rideride.net. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Jeremy Boyd. He's a CTO at Raygun and an expert on all things scale and APM. What is APM? I hear this a lot.
G'day, Scott. Thanks for having me. Well, APM stands for Application Performance Monitoring or Application Performance Management, depending on which flavor you take. Really, in a nutshell, it's about looking at server-side performance. What is your application actually doing? And an interesting sort of way of thinking about this is that when we build web applications, for example, we load the site and we get really good data in the browser actually these days about what is happening with a request. And what you generally find is that the longest time is waiting for things to come back from the server, right? The code that you wrote just takes time to execute. And you often wonder, what's going on down there? Why is it taking so long? Is it a bad query? Is it some bad code that I wrote? And so APM is all about trying to demystify that, really give you the insights into what's going on down there, and more specifically, what is it that could be a problem that you could actually then take some action on and fix and improve the situation.
Now, I might be making myself look bad or giving away secrets or not good secrets, but 20 years ago, when I was doing really large financial services systems, at least large for the late 90s, early 2000s, we were still spending a lot of time parsing logs, running log parser, sucking logs into SQL Server and trying to figure out what was going on. And we would do these things much like forensically. We could tell you what happened afterwards, but there was very little what's happening right this moment going on. When did that start to change?
That's right, and I remember those days as well, and I'm actually pretty glad that we've moved past a lot of that. When this sort of changed, in my opinion, I think is really when we saw bandwidth really increase, and people, particularly for hosting environments and for getting access to this data, bandwidth became less of a problem. And also the proliferation of the cloud, which allowed us to really ramp up resources to meet this sort of scale challenge that you're faced with dealing with increasing volumes of data, particularly when you start measuring things at an increasingly smaller and smaller level. This, just as a bit of a tangent, I guess, one of the interesting things that we sort of found when we got into the application performance management space is what's actually going on under the hood. And as it turns out, there's an amazing amount of things going on under the hood. It kind of reminded me a little bit when I was younger. You'd read Scientific American or something like that and learn that, below the level of the atom, there's another level. And it's kind of like that with the code that we write. And so as we delve down, even a simple program like Hello World, console.writeline Hello World, even though on the surface that only looks like it would take two method calls, enters main, enters console.writeline, and exits. There's actually hundreds of underlying calls that go on in the .NET framework to actually support that. And so as you start to kind of measure down to that level, the amount of data that you can start, generating and interpreting starts to really mass up. And I think, in the past, we were never really able to take on board all of that data all at once. We couldn't put it through the network fast enough. The machines that we had access to just simply weren't fast enough to process that. We could do, batched processing or a lot of offline processing and crunch those numbers over time, but we never really had access to it in a way that we could look at this stuff in real time. And I think between the cloud, between that sort of increase in bandwidth, we've been able to start unlocking some of these new realms that exist below the surface.
Yeah, I remember in production, we used to worry about things like, well, you don't want to turn logging on in production, certainly not on verbose or diagnostic, because you're going to be filling up the disk or filling up the pipe or whatever. Like if you're doing aggressive logging, you can, the perception was, at least when I was starting out, that you're not scaling if you're doing all of these logging. But do we have enough perf and enough pipe now that we can be a lot more verbose in our logging?
Oh, you sure can. Fair to say there's always a trade-off for these things. I mean, it's interesting because certainly when you delve into this realm, performance is becoming much more of a concern for you. For people who are looking at APM solutions, a big question on their mind is, how can I improve performance of my system? And so, one of the things you don't want is to necessarily degrade the system by putting in some sort of invasive approach, like you mentioned, the logging, which, that will generate a lot of I/O. So that would hamper things if that's not, managed properly. So, but we are able to really sort of solve this now, partially because machines are a little bit faster, we've got better resources, but also because we're now offloading that data not necessarily locally, but through a network, through to the cloud. And that again, that sort of couples with that bandwidth story. We've got the ability to kind of just send vast amounts more data than we would have thought about in the past as being sort of real or possible.
Right. So then you're saying that the simplistic perspective that I was doing 20 years ago was logging or maybe log shipping, but now it's events, it's exceptions, it's internal, and it's how deep you want to go in the stack. And then you're offloading all of that, get it off of the machine as quickly as possible and into some kind of a pipeline or an ingestion pipeline. That's
exactly right. Yeah. I mean, so conceptually how our sort of approach works is that we say for .NET profile, there's profiling APIs in .NET, which for anyone who would love a good little adventure, a bit of a geek adventure, I can highly recommend actually looking into the profiling APIs just to learn a little bit more about how the .NET framework actually works. It's really enlightening. Quick sort of example of that is, going back to my mention of under the hood, there's actually hundreds of these method calls happening on a simple program, even like Hello World. The Hello World example for, say, the full framework would generate about 200 odd method calls under the hood, where, and you don't think about this, it's things like, system.globalization, because it's writing to a stream, which then goes to some output source, which has to be formatted for the local culture. It's a stream, so it's got a lot of mechanics under the hood there. So all of that is, quite interesting to understand how it works. And when you sort of get down to that level, you suddenly realize, well, actually, there's a lot going on here, and there's a lot I could potentially control and manage the performance of. And that sort of, we learned a lot of that through building an APM tool, and then sort of that gave us new insights, I guess, and a new level of kind of understanding of that, how things work and where the optimizations might be able to be gained, potentially by looking at how the sort of framework itself has actually been built. We're quite lucky these days with the core CLR, the work that's been going on in .NET Core, because that's in the open. And, a big focus in .NET Core has been on improving performance of the framework. So I do a lot of watching of the commits that go into the .NET Core repositories, often just to kind of, look at where are things being tuned and what are the techniques that are being used to tune, performance in the framework itself. Because a lot of the time those techniques are actually transposable to the code that you might write, particularly when, again, you're looking at your system and you're thinking, well, this area is slow. And you've delved into, a specific enough sort of view of it to say, right, well, it's this method or it's this kind of algorithm that we're operating over that's sort of not running as well as it could. What are our approaches that we could look at to tune the performance here? Mm-hmm. So, we applied a lot of that in our ingestion pipeline because, as you kind of mentioned, there's a potential to just generate an amazing amount of data by sort of observing what's going on in a process. And, we have to deal with that data. And, as sort of data comes into our system, we have to kind of take a look at it, figure out what it represents. We do a lot of work in terms of kind of rationalizing the view of what happened in a program and presenting that nicely, for example, using a flame chart to a developer so they can better understand and sort of focus in on what is it that really is going to make a difference to improving my system.
How important would it be then, though, to not look at some of those events? I mean, like, you really want to monitor what matters. And like, there's a joke I heard on Twitter recently that said that the biggest crime that the C programming language ever did was that they convinced the world there wasn't a runtime. So someone might hear you say, well, there's like 2,000 things happening underneath console.write line. Yeah, .NET sucks. But console without write line, doesn't get even close to the metal. No matter what language you're writing it in, there's always something underneath. But do they really matter? If I'm trying to do hello world at scale, I probably can lose some of those events.
Yep. You always have to put this stuff in perspective. You could optimize the hell out of anything, but you have to kind of put it in perspective of what's going to make the best impact for the objectives I'm trying to reach with this system. Is it the fact that I want my customers to have a certain experience, and that infers a certain load time, which infers that I need to kind of target performance on certain queries to meet certain SLAs internally? I'll focus my efforts there. I'm not going to focus my efforts necessarily on, shaving off another few nanoseconds off this particular function. So the context certainly matters. And again, a big part of what our job is really is to try and highlight where is it that the big wins are, where you're going to gain performance to try and, meet those objectives that you've got about what your system should be doing and how your customers should be experiencing it.
Mm-hmm. What about some of the, if you think about it from a more philosophical perspective, I like to think about the Heisenberg uncertainty principle, that I can observe something and tell you where it is or how fast it's going, but not both. When we observe systems, large systems like this, when we instrument them, are we taking a chance that it might not behave the same way it did? Because we don't want to say, well, it worked on my machine, or it worked before I plugged in an APM solution.
Yeah, certainly that's always a concern. Another thing that kind of comes into play is that, isolated observations are always just going to be that. They're just going to be a snapshot of the activity at a given point in time. And that doesn't necessarily mean that that's how the rest of the requests or the rest of the interactions with that particular method or particular endpoint are going to always behave. Mm-hmm. And so, again, it's about building up a big picture of this over time. The good thing about putting in a solution like this is that, and having it kind of observing for longer periods of time, as you build up a better holistic view of what's going on in the longer term. Is it just certain types of users, and they might be, important users, or they might just be kind of different in the way that they're interacting with my software? Those users are having a problem, but everyone else is fine. And, information is power. So taking a lot of that insight in and be able to kind of make informed decisions about where to deploy your time and effort, because at the end of the day, for most of us, doing development, cutting code, there's a never-ending list of things to be done, and really a lot of the time we just want to focus ourselves on the things that are going to make the most difference and actually achieve good wins and, get all the good positive feedback out of that. The last thing we want to do is make an optimization that was just not actually worth it or anything like that. Mm-hmm. There's always an overhead with bringing in some kind of observation approach, like monitoring tool, a logging framework. So you just have to keep that in mind, and that's where we often do an approach where we'll do an A/B kind of deployment of something where we put a new approach in, we measure how the baseline looks, we'll put it in, we'll measure the other side afterwards. What's the impact of putting this technique in play? That's important. You've always got to measure things and just kind of understand and put that back into the context of, what am I trying to do here? What was I trying to achieve?
Actian Zen Database is the best-in-class, single, secure, scalable architecture for edge data management. It's the perfect solution for software developers who want dedicated application data management and deliver business-critical products and services into OT and low IT environments. Customizable installation, self-tuning, seamless backward compatibility, minimal memory requirements, and exceptionally low support requirements. And better performance than most alternatives like SQLite all means that you can deliver applications to customers at scale across a wide range of platforms. With direct access from C++, Python, and other popular languages, Zen's simple set of APIs significantly expands the pools of developers capable of building their next business-critical application on Actian Zen. Try it today at actian.com/Zen. That's actian.com/Zen.
I've heard that there are profilers that are listening all the time and APM systems that are paying attention to everything. And then I've also heard the idea of a sampling profiler, or it looks at 5% of the requests. Do you have thoughts about whether that's a good idea or not?
I certainly think sampling is a reasonably good idea. There's certainly an overhead involved with, particularly for .NET. the implementation of how profilers work with the .NET framework, which again, kudos to the efforts that are going on in .NET Core. One of the things that's happened there is there's better documentation has sort of surfaced around how to interact with the profiling APIs that exist in the .NET framework and in .NET Core. But there's always an overhead of using that sort of approach. You can reduce the impact of that sort of thing by taking more of a sampling based mindset to this. Mm-hmm. Again, it's one of these things where you need to kind of find the right balance. If you sample too aggressively, you open the window to losing a lot of the outliers that might occur. Mm-hmm. Often it's a case where you often want to build up a big picture first, and there's a cost to that. Over time, you might feel there's a confidence level. You understand the nature of the data you're seeing come through, the trends. You've already identified where the key hotspots are, and you start to dial the rate of observation down accordingly, which would correspond to improved performance just through less overhead of that sort of approach being in play.
I see. So you could do something like have it be on listening for everything at dev and half the things at staging and 10% or something at production. Depends on your problem. And then, of course, all exceptions or anything bad that might have happened.
Exactly. Yep. And one other sort of approach that we certainly are pushing in this space is the idea of leveraging this more for supporting debugging scenarios. One of the key challenges that a lot of developers have, particularly when things go into production, is that you lose your access to kind of instrument or get really detailed analysis of what's going on. For example, local state variables. What are the values of those method arguments that come through to parameters for method calls? Often a lot of that context is quite important to reproducing a problem or understanding how a problem manifests. Be it a performance problem, be it a crash. The context often is very critical to really understanding the nature of the problem. So, one of the things that we really sort of have spent a lot of time looking at is how we can leverage this sort of capability to try to really support those production debugging type scenarios where you kind of know the heuristics of how a problem is going to manifest. It's going to be this user at this time of day with this type, at this endpoint, and we've seen this behavior, and I just want to know more about it. And mm-hmm. So, the controls are there to allow you to just, so instead of rule, when this type of thing is in action, in play, give me more data about it. But every other time, just don't send as much data about what's going on because I'm not going to be looking at it and I'm not interested in collecting all of that.
I see. So it really is something where you don't necessarily dial it up for the entire application, but you might categorize things like the shopping cart's acting weird. Let's dial up logging on the shopping cart or dial up all events for the shopping cart for a period of time.
I mean, there's always going to be areas which you're going to be focused on. Today, this week, we're really focused on the shopping cart, and we really need a much richer level of information about what's going on there to make better decisions about what we need to do. We're in that investigation phase. We just need to collect a lot of data in this space. But everything else, that's just business as usual. Let's just sample that. Let's not collect as much information. We obviously want to know what's going on there in case any problems do turn up, but we don't need as much detail.
Now, oftentimes when you've got mobile devices or local applications, an app that I'm running on Windows or an app that I'm running on my iPhone, there's privacy concerns. I want to make sure I'm not, like no one likes, a lot of people don't like telemetry. They don't want to be kind of quote unquote spied on. On the web side, you have a little bit less control. If someone's implementing an APM product, how do they make sure that they don't accidentally leak information out? You don't want to necessarily throw a credit card across a boundary into some third-party APM system. Do you have filters, or what's the best practice for that?
Yep, that's a really good question. I mean, data privacy is quite an important concern in our space. The nature of the problem is quite vast, really, because as you kind of allude to, the opportunity to just send sensitive data across the wire when you're looking at things more at a system level rather than thinking so much about the data that's going on through these systems, the opportunities are vast. Whether that be PII information or, access tokens, which would give you, an opportunity to escalate privilege into a system. Those are all of concern. Our general approach for this is to allow people to sort of filter out the information to kind of effectively give you a hook in before the information leaves your boundary to our system to sort of do any kind of data sanitization, meet your own requirements, as it were, in terms of what data is sensitive. Usually this can be expressed with patterns or regex. So that's kind of typically how we deal with this problem. We also, particularly with other products that we build, like crash reporting. It's more a case of there's some standard things, like a lot of it's going into web systems. So, you're always going to look at the form. You're always going to look at what's coming across in the query string, user input. That's where this information is likely to be coming from. So let's just scan that for known patterns first, and you can get rid of a lot of that information by default. But then, there's always going to be system-specific stuff like those security tokens, or just things that only the developer of that system would have an intimate awareness of, that will require them to really kind of ensure that data is removed prior to sending it up to a service like ours.
Now, of course, in the interest of full disclosure, there have been episodes of the podcast that Raygun has sponsored in the past. But of course, for this conversation, one of the reasons that I called you and wanted to talk to you was the scale that you're running is just bananas. You're saying billions of events. I wanted to understand how one scales like that. And do you get backed up? Is there a queue? What's the queue like? I just can't quite get my head around the scale at which you ingest information.
It's pretty vast, I have to tell you. And again, sort of going back to that sense of, where we were 20 years ago, I would never have really dreamt that, the rates at which we kind of can ingest information, when you're dealing with the whole internet as your potential source, there's a real, it's very, very easy actually to just completely overwhelm yourself with traffic. So in terms of how we sort of went about it, I actually took a lot of, vision or inspiration from early talks that came out of Amazon, how they sort of did their scaling. They sort of talked about how they really went through more of an incrementally sort of scaling approach. We rebuilt the system because we reached the scaling point, and then we rebuilt it again because we reached another scaling point. And so we've kind of progressed in a similar way. We initially, when we sort of embarked on this journey, we were kind of a different company and we did different things, and this was just an idea. And so at that point, you don't really want to overcommit to, this could turn into be a really, really massive thing. So we may want to provision ahead of ourselves. Instead, one of our other focuses has always been on cost and performance, squeezing out everything from the dollars that we spend. So for us, it was a case of, let's get something in that's going to see us through to, 10 times the amount of customers we've got now, and then 100 times the amount of customers that we've got now, and then 1,000 times. And, to be fair, along the way, we've certainly been, tested and frightened a little bit by how much data we can actually get. There was one time early on that, in fact, it was only a few weeks into having launched our system where a new customer came on board, and all of a sudden they were sending at rates that were sort of tens of thousands of times above what we had seen before. I remember being sort of online one night, and the pager alerts went off, and it was like our sort of internal buffers were being saturated. And we literally had sort of seconds before they were about to run out by the time we dealt with the problem. And so a lot of the time it's just about, just scaling one step ahead of yourself. So that sort of notion of scaling our systems is actually just sort of a continuous cycle for us. We're always thinking about where are the bottlenecks? What are we going to be doing to kind of ramp this up so that we can sort of like 10x the volume through this section of the pipeline, and just really approach it in a sort of methodical fashion like that.
It almost seems like you're every day preparing for a benevolent DDoS, where someone's going to distribute, do a distributed denial of service on you, except they're using your APIs and your own product against you without meaning to. Sorry, we turned everything on verbose. And you have to be ready for anything.
You'd be surprised at how much that happens, yeah. And it's just the nature of this, and to be fair, this is what the cloud has unlocked in a way. It's unlocked the ability for, the internet to be hitting you pretty regularly. And so by design, when you kind of set yourself up with that model, you are effectively asking for a DDoS at any given point in time. And so you just have to be prepared for that, and build a bit of resiliency into the system to just know that that's actually going to be a thing that you're dealing with all the time. And we're at a certain scale. There's plenty of people who are at a much bigger scale than us, so we can take inspiration and learnings from what other people are doing. They might be in a different stage of their journey, but another great thing, certainly in the last sort of 10 years, which I'm sure you'd probably agree with, is that there's a lot more sharing of this information, of the learnings, of the fact that we're dealing with these challenges here. Maybe it's not the most elegant solution that everyone uses, but here's the ways in practice that we deal with these problems, and we're all learning, we're all incrementing, and we might find better ways over time. But it's really heartening that we as a industry are able to kind of collectively level up in this way.
Mm-hmm. Now this is built in .NET Core, but your SDKs are all languages. Like it doesn't matter; it's all HTTP. But you picked .NET Core on the back end. Is that correct?
Yeah, originally, we're very much, historically a Microsoft shop. Both JD and I, JD, my co-founder, we were .NET developers. So, it's a common thing. Developers go with what they know and what they trust. So for a long time, we were leveraging full framework. When .NET Core started to appear on the horizon, we were quite interested in it, particularly with the view that there was going to be a lot more iteration in that framework. So there was the opportunity to get involved as well with, looking at how the framework works, submitting a pull request. We haven't really done too much of that in practice, but, we've been able to leverage off the great ethics that exist in the community. There's people like Ben Adams who have really put in a huge focus on performance in the framework. We're all the beneficiaries of his, amazing work. We're really in the transition phase now of trying to port as much of our ingestion pipeline over to .NET Core as quickly as possible. There's amazing sort of performance wins that we can unlock by using .NET Core. And obviously from our thinking more holistically as a CTO, the technology choice is just a one-to-one, right? It's still .NET. It's still building using the same base class libraries. There's a little bit of difference there, I guess. But at the end of the day, it's very, very familiar, and it's, still as productive, and you're still using the same tooling and the same tool chain and all the build systems and all of that. So it makes the switch quite easy. I think I've also sort of derived a lot of confidence from, Microsoft's sort of stance on this, which is, this is the bleeding edge, but, we're going to bring back a lot of the good stuff and try and, land that back into the full framework over time.
If I were going to build something big, real big, the thing that I always worry about isn't that I can do it or not. It's that the thing that I'm building on top of is not going to have some weird, insidious problem, like underload, whether it be Node or Go or .NET or whatever. There's always that concern that you're sitting on a stack and you just don't know if it's going to have a memory leak or blow up under pressure or have some fundamental architectural issue around threading or async or whatever. How do you deal with that when you're pushing so much traffic through such a huge pipe? Did you think about that in the context of .NET or .NET Core, or did you test for things like that?
Early on, we probably wouldn't have thought too much about it at all, really. We were committed to building in .NET. We built in .NET. Over time, obviously, as the scale started ramping up, performance became far more of a thing, it becomes a feature. It's something that is ingrained into our thinking. It's ingrained into this, the way in which these parts of our system have to work. So over time, we've, I guess, gotten a lot more into really benchmarking and understanding what's going on. Where's the time going? Like I sort of talked about at the beginning with why you'd use an APM tool in the first place, this technique kind of obviously just goes, can be applied further to, how's the framework looking? We can measure that as well. So, and we can obviously just benchmark the system as a whole and understand, okay, where's it slowing down, and, why is it potentially locking up, or where's the contention? Is that a framework problem? Is it something on our side? Again, you kind of mentioned, you wouldn't want to be building on like a house of cards. And with the full framework, I never particularly found any issues there. But, as we've sort of seen with the development of .NET Core and all of the community contributions, there's plenty of room on the table still to improve performance. And but that hasn't necessarily hampered anyone in terms of delivering systems. But it's really nice to know that that's a far bigger focus within Microsoft, and certainly the development of .NET Core and the continuing kind of evolution of it, that a lot of people are dealing with these problems. They're concerned about performance. They're interested in making sure the framework's as tight as possible. And, those contributions all kind of come together, and we all benefit from it.
Right. And it seems like there's subtle things. Like I know that some people feel like .NET folks talk about span of T too much, like it's the biggest thing since LINQ or the biggest thing since, generics. But it feels to me like not, avoiding unnecessarily copying around stuff that you already have in memory is a pretty big deal. And the underlying parts of .NET Core that have been improved by the span of T would probably benefit an APM system as well.
I think that'll benefit most people, to be honest. One quick example within in the context of our ingestion pipeline that where this makes a big difference is JSON serialization or deserialization, right? That's something that historically everyone just kind of uses a library for, and you just don't really think too much about it. Everyone kind of knows that it's kind of slow. One of the reasons it's slow is that there's a lot of memory allocations and sort of copying that goes around, because you're dividing things up and creating new little objects to represent the object model and all of that. And by using a technique like span, which at the end of the day it's just a fixed sort of pointer across a block of memory, where you can avoid those allocations just by repointing, and this copy is just these bytes from 4 to 16, rather than we'll copy it and incur all of that cost. So everyone who's using JSON serialization and deserialization today, and if they're able to move to .NET Core 3 where those improvements have been made, they will benefit from that for free. So those sort of performance wins, while using span is definitely a great thing, where you can leverage it. It's good to see that that's been kind of baked into the framework itself, so that even if you're not necessarily thinking about these things or don't want to think about these things, they're not really top of mind, they're not a major concern, you are still going to pick up the benefits of having these things brought into the the worldview of .NET.
Very cool. Well, thank you so much, Jeremy Boyd, CTO of Raygun, for talking to me today about the world of application performance monitoring, management, however you want to call it. I've learned a lot. I appreciate your time.
Thanks, Scott. Really appreciate it.
This has been another episode of Hansel Minutes, and we'll see you again next week.